Welcome back, chemistry fans. Today, what we are going to embark on is gas laws. We have talked about the properties of a gas. We have talked about how to make it into a gas, but now we got to talk about how we can measure these gases. So I'm going to jump right into it. And we are breaking this topic up into two pieces because it has a lot of formulas, and I think that it was best that we just do a slow roast on it. Okay. The ways in which you can measure a gas. Now, we can qualitatively describe gases according to color, taste, smell, but those don't do us a whole lot of good whenever we want to measure quantities. So what we've got to deal with is volume, which will be symbolized with a capital V, temperature, symbolized with a capital T, pressure will be symbolized with a capital P in this formula. Now, here's the one that's a little bit odd, the number of moles of gas, the amount of moles, and that's a lowercase n that you would have to get used to. Some of the things I want to remind you about these properties that we measure is how to convert them. Many times you will be given these quantities of gas in milliliters. To convert them into liters, you need to remember that there are 1,000 milliliters in 1 liter. In other words, you would need to divide by 1,000, or you would need to move the decimal point back 3 places. In other words, if you were given 4,000 milliliters, that would be equal to 4 liters. If you were given 375 milliliters, that would be 0.375 liters. So divide by 1,000 or move that decimal point back 3 places. Now, this is a new conversion that we must become familiar with. In this equation that we're going to utilize, temperatures must be in the unit of Kelvin. The reason for this is because we want to avoid any negatives in our equation. The smallest temperature that can possibly be achieved is negative 273 degrees Celsius. That is the coldest temperature. That is basically the absence of any matter. That is approximately as close as you can get out in space. There is a little bit of dark matter and a little bit of radiation out there, but we are pretty close to that temperature in space where there's not much matter out there. So to avoid having this negative value occurring, what we would do is add 273 to all of ours, and then the lowest temperature we could ever get to is 0, and that's theoretically impossible. So, K. And so what we will do is if we are given 50 degrees, we will add 273 to turn it into a Kelvin unit of temperature. Now, as far as moles are concerned, we have to be mindful that we have an entire unit, unit 4, where we talked about how we convert moles to grams, you multiply, or if you have grams and you convert those into moles, that is a division process. What are you multiplying and dividing by? The masses that are on the periodic table. So in other words, if I have 50 grams of O2, we could convert that into moles by dividing by the weight on the periodic table of 2 oxygen. So 50 divided by 32 is 1.6 moles. If we were given 2.3 moles, and for some reason we need to convert this into, we would need to convert this into grams, multiply that value times 32, and 73.6 grams of O2 is what we would have. And those values, again, come off of our periodic table. All right. Now, a pressure is a new unit that we have to understand. Pressure is, in fact, a measurement of how much force there is on a surface. Now, what that means is how many gas particles are hitting a surface in 1 second is essentially what this is. The more particles hit it, the more force there is hitting it, the more pressure there is. If they are moving faster, they will also have more force, which equates to more pressure. So we're going to have to examine pressure a little bit more because we're not quite so familiar with it whenever we start talking about the units. Speaking of which, pressure has so many units. The other ones, pretty straightforward. We needed liters, we needed moles, and we needed Kelvin. But in this scenario, we have several different units. We have pascals, we have bars, we have torrs, we have PSIs, we have atmospheres. All of these units are what we are going to have to be able to convert whenever we get into our discussions and using this equation. Here, those same units are with their conversion factors. These are all equal to one another. So 1 atmosphere equals 1 bar. They are essentially the same. 101 kilopascals equals 1 atmosphere. 760 millimeters of mercury or 760 torr equals 1 atmosphere, and 14.7 psi equals 1 atmosphere. Now, there is another scenario that could develop whenever we deal with this equation. They could forego giving you any specific data and just say the measurements are taken at STP. We need to be aware that that means the pressure is 1 atmosphere and the temperature is 273 Kelvin. It's just a shorthand way of saying these are what the temperature and pressure were measured at in the laboratory. Now, along with that, though, they could state that it was measured at ambient temperature. Ambient just means the room temperature or the circumstances outside, whatever that temperature is. So wherever you are, that's the ambient temperature. So like today, I woke up and it was 30 degrees ambient temperature outside, but it was a balmy 70 degrees ambient temperature inside my house. So it depends where you are as to what ambient temperature means. Now, they have defined, though, standard ambient temperature is going to be 25 degrees. So if they talk about a standard ambient temperature, you have to understand that that is not STP, that is 25 degrees. Now, taking all of this into account, these again are the 4 variables that we need to measure. We are going to put them into an equation. This equation is PV equals nRT. We've already talked about pressure, volume, and temperature. Number of moles is using the mole map, but this stands out as odd. We have not talked about this variable in the equation. So here is where I'm going to mention it. It is a constant that needs to be applied to the equation based on the unit of pressure. In other words, if the pressure is in atmospheres, you would use 0.0821. If the pressure is in kilopascals, you would use 8.314. If the pressure is in millimeters mercury, you would use 62.4. And if the unit is in PSI, you would use 1.2. So let's put all of that together, and we have the ideal gas law, PV equals nRT. So let's go and practice it. We got 2 problems that we need to deal with. So my first step of advice is that you would write down the equation PV equals nRT so you know where to substitute your values. It says that we are looking for the amount of gas. Now, you may not be familiar with which letter that is, but we can read the question, and it says that the pressure is 2.1 atmospheres. It says that the volume is 8.5 liters, so we can substitute those into the correct places. I don't know what N is, so I will skip it. My R value is something that I can skip. My temperature, it does say, is 298. So I'm now going to go and find an R value off of that chart that matches the pressure value that was given to us in ATM. So it says that when I have a pressure in ATM, my R value is 0.0821. So I'm going to plug that in. So 2.1 times 8.5 equals 0.0821, N times 0.0821 times 298. All right, so now what we've got here is an opportunity to solve this algebraically. So I will get that N by itself. N happens to be the number of moles, which is the amount of gas that is in the question. So now I cancel out, and I've got N over here. So I am going to take that, I'm going to divide by 0.0821 and divide by 298. So I've got 2.1 times 8.5 divided by 0.0821 divided by 298, and I end up with 0.73 moles. How do I know it's in moles? Because the unit for N is moles. All right, let's move down to 27. Another example problem. This time I'm not told what those units represent, but I do know I'm starting with PV equals nRT. Also, I want you to notice that all of these units are not what they need to be in. For example, 45 degrees Celsius, I need to convert that into Kelvin. So 273 plus 45 gives me 318. The R value needs to match the pressure value. Well, I'm not quite sure what, oh, no, I am. Here it is. Pressure is 790 millimeters of mercury. And you're saying, how am I supposed to know that? Because it's a unit that you are unfamiliar with. So I'm going to go now and I'm going to look for the R value in millimeters mercury. It's 62.4. My N value is unknown. That's what is not given to me. This is in milliliters. That means I need to divide by 1,000. That means I've got 6.87 liters. So again, I'm going to isolate that N. I'm going to divide both sides by these two values. Bring them onto the other side because this is what algebra does. And I'm going to end up with my answer, 790 times 6.87 divided by 62.4 divided by 318. And I end up with 0.274. But this is in moles. It is asking for grams of methane. I need to know that methane is CH4. So I will multiply the weight times, the moles times the weight off the periodic table. If I look up, carbon weighs 12, each of the hydrogens weighs 1, that is a total of 16. So I've got 16 times 0.274, and I end up with my final answer is 4.38 grams. This is everything that I wish to share with you about part 1 of the ideal gas law of gas laws in general. We will break this down further in the next topic. Thank you very much for staying with me today. Talk to you again soon. Farewell. Bye-bye.